So question 11 says, match the graphs with the functions. So again, we have a bunch of functions and 4 graphs. And if I look at the graphs, it looks like the top 2 are quadratic or square functions, if you will. So it looks like y equals x squared up here, and then we looks like we have some absolute value ones down here again. If I look at the first one, it looks like, again, it's opening down. So look, there's a negative, there's a reflection over the x-axis, which means the negative's got to be on the outside since that's an up and down motion. And it looks like it's been moved to the left. So that means we should have something on the inside as well. So it looks like the quadratics are involving these 2's. So if it's left 2, it's got to be a plus 2 on the inside. So what I'm thinking is we should have like a y equals a negative on the outside, an x plus 2 squared is what I'm thinking. That should make the graph flip upside down and move to the left 2. So if I double check that, in negative and then in parentheses, this x plus 2, close that parenthesis and square it. If I graph that, yeah, that kind of mirrors the first one there. So y equals the opposite of x plus 2 squared. So it looks like this one here would drag down. The next one, it looks like all it's doing is opening down. I don't really see it moving on that one. It may have a stretch involved because it looks like it's a little bit skinnier. So that actually may have an actual vertical stretch because it is a little bit more narrow. So stretch means it's moving more vertically, which means it should be a little bit closer to the y-axis. So it looks like, to me, this one here looks like the best one because there's not really a translation. It's more of just a stretch. So y equals negative 2x squared, because if the 2 would make it move vertically a little bit there. So if I go over here and put a negative 2x squared in and graph that, that does seem to mirror what's happening to the graph there. So yeah, those 2 match that. This one here, it looks like all we're doing is moving to the right, and the absolute value functions looks like we're involving these 3's. So if it's moving right 3, that means the 3's got to be on the inside. To make it move it right, it's got to be the opposite of that. It's got to be a minus. So if I have y equals x, absolute value of x minus 3, that should make the graph move to the right 3. So what I'm thinking is it's this one here. So if we double check that, y equals clear, and then put the absolute value would be math number 1. And if I put the x minus 3 inside there and then graph that, that should make it move to the right 3. It does, so it looks good. The next one, it looks like there's no movement. It looks like it's just a little bit narrower. So it looks like that's a vertical stretch. So y should equal, it looks like it's going to be 3 times the absolute value of x. That'd be one way to look at it. That would make it kind of move vertically by 3. So I'm thinking this one here should match that. So if I type in y equals and clear that off and put a 3, and then math number absolute value, if I put the x inside there and graph that, that does kind of mirror what we have there. So that's what I'd be picking up on there for those questions